So today we're going to discuss absolute value inequalities. Tell me how that's different than last week. The others were equations. Okay, these are inequalities. Now I'm going to start with this problem right here. Absolute value of x plus 8 minus 5 equals 2. This should look kind of familiar to you because it was on your homework, right? It's one of your homework problems. First of all, let me clarify, is this an absolute value inequality? It is not, right? It's an equation. I would like us to go through the steps again from the last time we met to make sure that we are still together, okay? That we're on the same page on this. So what is step number 1?
Do not panic.
Do not panic, okay? For absolute value equations, what's our next step? Isolate the absolute value, right? So how do I go about getting the absolute value by itself? Or add 5, right? Okay, if I add 5, I get the absolute value of x plus 8 equals 7. Is the absolute value isolated? Yes, so what's our next step? Two equations, right? I need to set up 2 equations. What's my first equation? X plus 8 equals 7. What's my second equation? Negative x plus 8 equals 7. And this is where I ask you to trust me, right? And said it will make, when we meet next time, much easier, right? So today I'm going to show you why it makes it much easier, all right? But let's continue on and solving these and make sure we remember the steps. Once I have 2 equations, what do I do with each of them? I solve them. So subtracting 8 from both sides gives me x equals negative 1. And what are we doing here? Dividing by negative 1, which gives me x plus 8 equals negative 7. So I subtract 8, and x equals negative 15. And then our last step? Okay, so negative 1 plus 8? 7. What's the absolute value of 7? 7 minus 5? Does 2 equal 2? Okay, so I know that one's right. Negative 15 plus 8. Negative 7. What's the absolute value of negative 7? 7 minus 5. Does 2 equal 2? So I know that those 2 answers are correct, right? Now let's start today's assignment, today's work. We remembered all our steps from last time, right? Look at what the first example is going to be. Absolute value of x plus 8 minus 5 is less than 2. Does that look familiar? Yeah, what's the only difference? The sign, right? The inequality sign. I need us to take a quick commercial break. Can we take a quick commercial break? Okay. For our commercial break today, we're going to talk about some numbers. Is 5 greater than 2? Is that a true statement? Okay, thank you. Am I allowed to add anything I want to both sides of the equation? And will it change the value? So I could add 10 to both sides of the equation. Is 15 greater than 12? Yeah, that's still a true statement. I can add anything I want as long as I do it to both sides, and it doesn't change the value of the inequality, does it? Am I allowed to subtract anything I want? Like 5? Is 10 greater than 7? That's still a true statement? No problem with that? 10 is still greater than 7, right? So I can add anything I want or subtract anything I want, as long as I do it to both sides. It's still a true statement, right? am I allowed to multiply both sides by the same thing? Is that allowed? Is 30 greater than 21? That's still a true statement? So I can multiply both sides by anything I want? We'll say yeah for now. We'll talk about that in a minute, but we'll say yeah for now. Okay? But what if I divide both sides by a negative number? Is negative 10 greater than negative 7? No, it's not. Okay? If I would have multiplied both sides by a negative 3, so if I had 10 is greater than 7, and I multiplied both sides by a negative 3, is negative 30 greater than negative 21? No. So what do we have to be careful of? Negatives, right? If I multiply by a negative number, or I divide by a negative number, what do I have to do? To make it a true statement, what do I have to do? I have to flip the inequality sign. Now, I appreciate your vocabulary, okay? Because I don't want you to just think, well, you flip the sign. Well, because some people get confused, because if I divide 30 by negative 3, didn't I flip the sign to get negative 10? Kind of, right? Not exactly, but kind of that's what's in their head. But by saying flip the inequality sign, you know exactly what I want you to do. It's negative 10 is less than negative 7. Yes? Here, it's negative 30 is less than negative 21. We're flipping the inequality sign, yes? Okay. Back to the show. What do I do first? What's my first step? Yes. What's my first step? Don't panic, right? My first step is don't panic, because just because it's a little bit different, I'm not going to panic. Okay? What's my next step? Isolate the absolute value. To isolate the absolute value, I add 5. Isn't that what I did up here? Yes. So nothing has changed so far, has it? So absolute value of x plus 8 is less than 7. Now that the absolute value is isolated, now what do I do? Set up two equations. My first equation is exactly like it is without the absolute value, right? The second one is the opposite of what's inside the absolute value, or the negative of what's inside the absolute value. Yes? What do I do on the what do I do now? What's my next step? So solve, right? I'm solving, and I'm going to solve by subtracting 8. So x is less than negative 1. What about over here? I need alarm bells going off in your head here, because I just divided by a negative number. So x plus 8. What do I have to do with this? I have to make it greater than. Okay? I have to flip that inequality sign when I divide by a negative number. And then I get negative 7, right? So all that's left to solve is subtract 8. X is greater than negative 15. Now here's the funny thing about the trust that you put into me on Friday. Okay? Last Friday, remember I asked you to trust me that we would do it, we would change the sign on the inside and not the sign on the outside. The funny thing about it is I don't want to spend the time showing you what would happen if I changed the sign on the outside, because that would waste all the time that we're saving by flipping or by putting the negative on what was inside. If you want to come see it in Bulldog period, I'll be happy to show you in Bulldog period. Okay? But you trusted me that it would save us time, and now you just kind of have to keep trusting that it's saving time. Because if I show you, then we're wasting all the time that we just saved. Is that fair? Okay? I guess if you think about it a little bit, you'll be able to see some of it. Okay? Now, here's the difference. Because up here, we were done, right? We got our two answers, we checked them, we were done, right? Down here, we're not done. Not this time. Because this is an inequality, so how many solutions do I actually have? I have a ton, right? I have a lot of solutions. I have to show those solutions on a number line, okay? And then I actually have to write my solution, because these are kind of like our preliminary solutions. That's what's going to help us with our number line. And then when we finish our number line, then we're going to write our actual solution. Okay, so we have like 2 more steps after what we've learned with equations. Okay, so these were our 2 endpoints on our number line. These are 2 important numbers. So over here is negative 15 and here's negative 1, right? First of all, what goes on the negative 1? It's just less than negative 1. So it's just an open circle on negative 1. How would it be a closed circle? Less than or equal, right? If it was less than or equal, it would be a closed circle. Why don't I have a closed circle on negative 1? Is negative 1 part of the solution? Or does everything less than negative 1? Do you see the difference? Okay. Now, which direction is less than negative 1? To the left of it or to the right of it? To the left. I'm not going to shade yet. I'm just going to tell myself where I would shade if I was going to shade. It's not time yet. Now, what goes on the negative 15? Also an open circle. Okay. Because of where this came from, will these ever be different? No, right? They will never be different, because these are going to be opposite directions, or they won't ever be the same direction, because at some point we're going to have to divide something by a negative, right? But one's not going to suddenly turn into a less than or equal to. Or if it starts with a less than or equal to, one of them is not going to suddenly turn into just a less than, right? So these are both going to be open, or they're both going to be closed. Does that make sense to you? Okay? Now, which direction is greater than negative 15? To the right of it or the left of it? Greater than is to the right, right? Now I need to shade either where they're both true or not. Here's what I mean by that. Can I shade right here? Yeah, because this one's less than it, this one's greater than it, right? So the only true part is where they are, where it's in between these 2 numbers. Okay? The only other possibility is shading outside of it. I'm either going to shade inside in between the 2 numbers, or I'm going to shade outside the 2 of them. Okay, I'll do one of those for you in a second so you see what it looks like. Is that all right? Now all that's left is to write the answer. Okay, now we have 2 ways to can write the answer. One way that I prefer, but I'm going to show you both ways. Is that fair? Okay, this is called an AND statement, because it's greater than negative 15 and less than negative 1. So you could write it this way. X is greater than negative 15 and X is less than negative 1. The preferred way that I would like you to do it is negative 15 is less than X is less than negative 1. Do you see that these 2 things say the same thing? If I took this statement right here and flipped it over and read it backwards, does it say the same thing as that does? This is one statement. This is the better of the 2, but the top is not wrong. Do you see the difference? Is everybody okay with that? Okay? Because to me, this looks like this X is between these 2 numbers. And isn't that what this number line looks like? The shading is between the 2 numbers. Do you see why I prefer this one? Yes? But I also want you to know that's an AND statement, because both of these are true. Can you tell me one number that is less than negative 1 and greater than negative 15?
Negative 14.
Negative 14. Right? Negative 7. Negative 3.2. There's a ton of numbers in between negative 1 and negative 15, isn't there? Okay? So that's why it's called an AND statement. Does that make sense? Yes? Okay. Are you ready for another example? Six times 1 minus 5x, absolute value. Oh, sorry. 6 times the absolute value of 1 minus 5x is greater than or equal to 66. Step 1, don't panic. Step 2, isolate the absolute value. How are we going to isolate the absolute value? Divide both sides by 6. Very good. Absolute value of 1 minus 5x is greater than or equal to 11. Is it isolated? Is the absolute value isolated? Yeah, so what's the next step? 2 equations. What's my first equation? 1 minus 5x is greater than or equal to 11. And what's my second equation? Good. Excellent. Now that I've written 2 equations, what do I do with them? Solve them, right? How am I going to solve the first equation? Subtract 1. Negative 5x is greater than or equal to 10. And now, if I divide both sides by negative 5, if I divide both sides by negative 5, flip your inequality sign. X is less than or equal to negative 2. You see how I flip that inequality sign right there? Everybody okay so far? Okay, solve the second one. Do you remember when I first taught you how to solve these when they were equations? I said we could either divide by negative 1 or we could distribute, right? Distribute was your first inclination because that's what you're used to. And I said that's perfectly fine. And then I showed you another option of dividing by negative 1, right? And I said there's times when one is better than another, right? This first time, dividing by negative 1 was better. This time, distributing is actually better. Can you think about it and tell me why distributing would be better? What's going to happen right here? That's going to be a positive 5, isn't it? The term with my x is going to be a positive. And if it's a positive, what don't I have to remember to do? I don't have to worry about flipping the inequality sign when I divide because it's already a positive number. Now, is it going to be wrong if you go ahead and divide by a negative here? No, but if I divide by a negative here, I'd have to flip the sign. And then when I go to solve for the x, I'd have to divide by a negative again, and I would have to flip the sign again, right? So there would be 2 places to mess up right there. So do you see why distributing the negative here would be better? Yeah? Keep your eyes open to see if your x term is already a negative. Whoop, what am I doing? If the x is already a negative, because if it is, distributing is a better choice. Okay? So here I get negative 1 plus 5x is greater than or equal to 11. Now when I go to solve by adding 1 to both sides, I get 5x is greater than or equal to 12. And dividing both sides by 5 gives me x is greater than or equal to 12 over 5. Now, is 12 over 5 a perfectly good answer? Yes, absolutely. It's a perfectly fine answer, okay? But it depends on what kind of number line that you want to, or that you have to show your answer on, right? Sometimes I'm just going to give you a blank number line and let you put your numbers wherever you want. Sometimes I'm going to put some dashes on this number line, like this. And sometimes I'm going to give you a number line that says this. And if I do, you need to know where that number lives, don't you? Where does this number live? 12 over 5 is the same as what? Like what 2 numbers is it between? What 2 whole numbers is it between? 2 and 3, right? Because 10 over 5 would be 2 and 15 over 5 would be 3, right? So this is between 2 and 3, so I'd have to put it right here, right? Yes? Now, when I put it here, is it a closed circle or an open circle? close circle. Now, is it halfway, exactly halfway in between? No, it's 2/5, which is a little bit less than halfway. But these, I gave you a really big one here as an example, but on homework, it's going to be very small. So as long as you get it in between 2 and 3, I'm okay with that. Okay? Where's the other colored in circle that I'm going to put on this number line? -2. So -2 is less than or equal to -2. X, excuse me, is less than or equal to -2. Which direction is less than -2? Left. Which direction is greater than or equal to 12/5?
Right.
Which way do I shade this time?
The outside.
The outsides. Here and here. Okay? Now, if the other one was an and statement, which one is this? Do you know?
Or.
It's definitely an or statement.
Oh my God.
Because, Caden, can you tell me a number that is less than -2 and greater than 12/5?
Nope.
There's not one, is there? So this time, you know, last time we could write the number like this. We could write it like this. This time we can't. It has to look like this, except right here it has to say or. Okay? We have to say x is less than or equal to -2 or x is greater than or equal to 12/5. Because there's not numbers that's less than -2 and greater than 12/5. So I can't write it as one sentence, one inequality sentence. Does that make sense? Okay? So if I ask you to circle your answer, what would you circle?
The whole thing right there.
That is your answer. The graph and the sentence. Does that make sense? Okay. I am going to try to trick you. Are you ready? Oh, that was a defiant look. He's like, you're not going to trick me? You're not going to trick me. I don't want to. But I'm going to try anyways. 2 times the absolute value of x plus 3 plus 10 is greater than 4. Step 1. Still don't panic. Why would people panic? Because I told you I was going to try to trick you, right? Okay. Step 2. Isolate the absolute value. What do you want to do first? Subtract 10. I'm okay with that. 2 times the absolute value of x plus 3 is greater than -6. And now? Divide by 2, right? Because the 2 is multiplying by the absolute value, so I have to divide it. What do you want to do now?
Add 3 to the percent. Or make 2 equations. No. Wait.
Jake's having alarm bells go off. Why is his alarm bells going off? Because it's negative, right? I isolated my absolute value and it's a negative over here. Didn't we say on the other day that this is when alarm bells should go off? Right? Why? So absolute value can't ever equal a negative, but this is an equality, so we have to think about it. When I take an absolute value, I'm always going to get what kind of number? A positive. When is a positive number going to be greater than a negative number? Always. It does not matter what I put in for x. I can put anything for x and it will always make this statement true. And my number line looks like this. Does that make sense? What if I started this original equation way up there, except this said less than? Wouldn't I do all the same steps? Except I'd get here, x plus 3 is less than negative 3. Alarm bells would go off because I have my absolute value isolated and less than a negative number. When is my positive number going to be less than a negative number? Never, right? And this is what my number line looks like. Sad and lonely. Do you see the difference in those two? Okay? Anytime absolute value is either equal or an inequality sign with a negative numbers, that's when your alarm bell should happen. And you know it's got to be something weird. It's either all real numbers or no solutions, right? Any questions?